before we start, let me just do a quick revision of complex number. You can write it even if you don't write it, it's fine, because I hope all of you just remember this. Okay, it's not very complicated. We have, let's say, okay, let's start the record. Yes, okay. So we have, let's say, a resistor and inductor in series. We can also have a capacitor. And in our lower classes, we've seen that the phase, okay, if you measure the voltage, there is a change in phase. And the resistor is actually 90 degree behind phase compared to the inductor, right? And how do we represent it on a page or on a plane? We can just represent it in this form, right? VL will be along the y-axis, which actually represents IVL. So it's a way to represent the imaginary voltage along the y-axis. And if you want to have the resultant, we can just take root over of VR square plus VL square. So this is where we use complex number idea. We also, in our lower classes, you might have studied about Argand diagram, okay? And there actually you can represent a complex and a real quantity on the plane by using the x and the y-axis, and the imaginary quantity will be represented by on the y-axis using the I symbol, right? We can have a function which will be having a real part and an imaginary part to it. If you take the mod of this will be giving you a value. So this one doesn't have any kind of physical significance because imaginary in real world doesn't exist. If I want to have a physical significance of this, I want to have a mod of this, and then only I can get some value which I can interpret. So similarly, what happens in quantum mechanics, we use this concept a number of times. We use the star. Star means it's a complex conjugate. इसका मतलब ये होता है कि whatever we have I, we will use a minus I in place of that. So A plus IB is the original Z value, and as soon as I write down the complex conjugate, it will be A minus IB. And then when I do my calculation, okay, I square is nothing but minus 1. So A square minus IB whole square, I can write it down as A square plus B square. So this will again have a physical significance. So you might have a quantity represented by some complex number, and if you want to have a physical significance for that, you should also take the complex conjugate of that possible. We have got sine function, we have got cos function, and sine function and cos function can also be represented in terms of I. Okay, this is how I think you can recall this. E to the power I theta can be written as cos theta plus I sine theta, and e to the power minus I theta can be written as cos theta minus I sine theta. So if we add them up, I sin theta get cancelled, cos theta will become 2 cos theta, and this side if I add up, it is e to the power I theta plus e to the power minus I theta. So cos theta can also be written in terms of an imaginary value or vice versa, right? So these are some uses of complex numbers that you might have already seen in your lower classes. Okay, why I'm revising this? Because eventually you will need it when we try to analyze waves. Okay, and we are going to talk about Schrodinger equation and so on. Okay, so this is just a revision, not a part of the syllabus, but you should know this. This is more important. Okay, so let's come to the topic that we actually want to take up today. The question is, okay, the question pattern will be like this, and this is very important, and this can be a descriptive question also, because there are a lot of things that we should know here. Okay, the question is, what is wave function of matter waves? So in general, whenever I say function, this will actually give me the information about the system, right? For example, you write down an expression like, we say fx means it's a function of x, and in general when we write it down, we can write it down as, let's say, x square plus 2. So it tells me a lot of information, right? If I know the value of x, I can predict what is the value of y. Okay, so this will become an independent variable, this will be a dependent variable. So this is a function. So that means at a certain point I can predict the position of the particle. I can find out both x and y, possible, right? So this is what is called function. Similarly, if I have a equation for a wave, I can predict the behavior of the wave at different positions, and that is why wave functions are important. So whenever we have a system and it is forming a wave, and if we know what is the relation by which I can represent that wave, I can give information about that wave or that matter wave. That is very important. Okay, so this is what is the importance of wave function is. Okay, so we are going to make some very important points here. Okay, And the first point would be, okay, uh, whenever we say, let's say, sound waves, okay, there is some kind of periodic variation. If we talk about electromagnetic wave, again there is some kind of periodic variation. So in matter waves, the periodic wave variation is in the wave function. Okay, so before I explain this, maybe we can just write down few sentences. Okay, it's important. So if we consider a wave, so every wave is characterized, okay, is characterized by periodic, you will understand this is not very complicated, something which you might have already studied, variation in some physical quantity, in some physical quantity. So I might say it's a sound wave, or I might say it's a you know electromagnetic wave. So what are the variations that are actually happening? Okay, sound wave. So as I speak and someone is there on the other corner of the room, okay, my sounds will reach to him, okay, via the air, right? So there is a change in pressure, there is a change in pressure. So what is the physical quantity that varies in case of sound? It will be nothing but pressure, right? So the air pressure will change at different points, and because of which the signal will get transferred. So pressure varies periodically. So whatever is a wave, and there will always be some quantity will actually change. Okay, and then I can take electromagnetic waves. So sound waves are longitudinal waves, and electromagnetic waves are transverse waves. So electromagnetic waves may be whatever ultraviolet radiation, electromagnetic radiations like visible light, microwave, and so on. Everything comes under electromagnetic wave, right? So they vary periodically, and the change that happens is nothing but the electric and the magnetic field. Okay, so this is also something which you might already know. So electric and magnetic field varies periodically. Okay, so this is also simple, already know, periodically. So if you have a wave, maybe an electromagnetic wave which is traveling along the x-axis, and you will have an electric field which may be represented by like this, and it varies periodically, right? You have this shape, and then you have this shape again after a definite period of time, so there is a periodic variation. Similarly, the magnetic field will also vary, and it will travel in a direction perpendicular to the electric field, so the magnetic field will also vary periodically. Okay, so this is the physical quantity that actually changes. So there will be some quantity which will change when basically you have a variation there. So periodic variation, so that's very important. So what is the quantity that varies when we are talking about matter waves? Okay, because it's kind of different. Yeah, we have already seen matter waves. We've learned about de Broglie wavelength. So in matter waves, what happens is, what we can say is, the quantity whose periodic variation make up matter waves. Okay, make up matter wave is called wave function. Is called wave function. So this wave function will vary periodically, and this wave function is something which you can realize physically, right? So it has got a physical interpretation. So we usually denote it by psi. The symbol for representing a wave function is psi. So this is the first point that I'd like to explain, and I think this is important. And what is the wave function of matter waves? You can talk about this. This is a prelude to this, and how exactly we understand what is wave function. Important. So next thing is, we should know what is the value of wave function at different points. That is also very important, and we will just write down few points on this. Okay, so I can write down the
value of psi, that means we've already said that psi is the wave function. Okay, at these things are important. There can be direct questions from this. You should also know it at the same point. At a particular point, okay, let me say it represented as x, y, z in space at time, let's say t, is related. I'll explain this to you. It's a very simple idea. It's a quantum mechanical idea related to the probability, to the probability. So you know whether it exists at a particular location or not, we can easily predict if we know what is the wave function. Is related to the probability of finding the particle there at that time. There at that time. So if I know what is the value of the wave function at a particular point x, y, z, I can easily predict whether the particle will be there or will not be there. Why wave function? Because we are talking about matter waves here. You have a particle, it will have some wave associated with it. If we can actually define that wave in the form of an equation, and we can predict what will be the position of the particle at different point. Okay, so this is an important thing that we should know. Let's take the third point that we should know about wave function. These are all notes that you need to make. Okay, I'm just writing it down so that you all easily can remember. Now if you just take psi, okay, if you take a wave function, you will see that eventually you can actually represent it in the form of some imaginary value as well. Okay, the maths will come up in that way. So this psi itself might not have any physical significance. Okay, that will be a bit difficult to realize physically. So itself, the next point, does not have any direct physical significance. This is important to understand. Direct physical significance, okay, and is not experimentally measurable. And these kind of ideas makes difficult for quantum mechanics, okay, to get comprehended. Okay, we sometimes feel that quantum mechanics is something which is very difficult to understand, but that's not true. Okay, you have to understand the quantum mechanics from a probabilistic point of view. So psi itself does not have any direct physical significance and is not experimentally measurable. These are important. Okay, if I ask you a direct question, these are the things that you're supposed to write down about wave function. Measurable quantity. Okay, why I'm saying this? Because psi can be positive, it can be negative or complex. It might have. So eventually when we start solving problem, we will see. Actually, I'm not going to do it right now, but eventually you're going to understand this. It's not going to be very difficult. Let's take the fourth point. So if psi is not physically significant, what is physically significant? Okay, so we can say the product. That's why I was talking about complex conjugate psi star. So I hope you now know what is psi star. Psi star means if whenever there is an I in psi, you can replace it with minus I. It's not that it will be there. If it's not there, you can just take the square of this. That's it. So this is real. Whatever may be the form, if you just take its complex conjugate and multiply it with the original wave function, you will find that this will always be real and positive quantity. Okay, so this is actually a bit of long journey. until and unless we finish the topic of Schrodinger equation, these things won't become crystal clear. But at this moment, I think all of us can remember this. Okay, this is important. So there is a very common and important question that what should be the property of a wave function to be acceptable in quantum mechanics. Okay, so what are the conditions that it should satisfy? So I will write down not a question, but at least I'll write down the point, but you can make the question out of it. So it can be okay, this is important. This is again a question which might be of around 2 marks. Okay, or maybe I can just write down this is important. So आप लोग सबको ये याद रखना है, ठीक है? And the thing is, what is the property of that wave function that we are talking about? So physically acceptable wave function, let me say psi. Okay, psi is the representation of a wave function mostly in quantum mechanics, should satisfy the following condition. I'm just going to take up one by one the condition. The following condition. What are those conditions? Number one, psi should be normalized. Okay, normalized. We will use these specific ideas to actually do a lot of numerical problems. So right now, don't worry. Psi should be normalized wave function so that psi square will represent probability. Will represent probability. So what happens is probability, as we all know, will vary between 0 and 1, right? Probability will be 0 and 1. So if someone says that the probability of raining today is 0.5, that means 50% chances of raining, right? So since psi is representing probability, that means that if I say 1, that means that particular particle is definitely present there. If I say 0, I can be sure that the particle is not there, right? And in between it will be all probabilistic. So that's the reason that we should actually normalize psi. That means whatever may be the value of psi star rather, because psi has no physical significance, this psi square must be equated to 1. This total probability should always be equal to 1. So I hope all of you remember your probability from class 12 maths if you have taken it up. Probability means that if it's 0, 0 probability. If it is 1, 100% probability of an event occurring. So if I'm saying that there is a wave function existing within a certain region, I know for sure 100% that the particle will be there, right? So 100% means 1. That means the total probability should always be equal to 1, and that's the reason that we should actually normalize the wave function. Psi should be normalized. That's a very important point. Okay. Next. As probability is single valued function. Okay, you're basically having a value which should be there. Probability, there is only one probability that you actually calculate, is single valued function. ये जो wave function है psi must also be single valued okay function at every point in space, at every point in space. What does it mean? You cannot have two probabilities at a single point. Okay, it will either be 10%, it will be 20%, 30%, it will be one fixed value. You cannot have different probabilities. In a similar way, if I even am talking about wave function psi, it will be single value. If we solve the problem and we find out the function, okay, and we solve it, we will see that at each point it will give only one single value. Okay, and that is the reason that we are considering it to be single value. These are the properties of the wave function that we are talking about. Okay. Next, these are the conditions that we should know, and I know today's class we are doing maths here. We are trying to understand wave function, and wave function is a big topic, so let's do it slow. Psi, जो मेरा wave function है, must be finite. Anyway, if it's infinite, I'm not going to solve the problem. It's going to get more complicated. It should be finite at each and every point. It should be finite at each and every point. Important. So we should be having a definite value of psi at each and every point. It cannot be something which is infinite, not defined, and so on. Not possible. Okay? And then finally, this is also an important point. Psi must be continuous. It should have some continuity. It should not break in between. That means there between two locations, between this point and this point, it should not be at some point it becomes infinite, okay, or it doesn't have a defined value, well-defined value. It should have some continuous value, okay. Must be continuous in region where it is defined. Region where it is defined. So I'm saying that the particle will exist from location A to B. It exists between A and B. I know it. So that means at each and every point between A and B, the wave function must be continuous. That's very important. If the wave function is continuous, that means its first order derivative should also be continuous. Mathematics tells me that the first order derivative also should be continuous. That means if I say the change of psi with respect to x-axis, or the change of psi with respect to y-axis, it can be three-dimensional, right, real life, or the change of psi with respect to the z-axis must also be continuous. And eventually we are going to understand why it is so, but now we should know all these 5 points. Okay, so this may be around 5 points, so maybe 2 marks question. Okay, 2 to 3 marks question. So I hope by now all of you are might have faced so many exams, and you know that whenever you are getting a question which can be written point wise, whatever may be the marks, the number of points should be double of that. So each point will carry half marks. So here also, if I'm asking you a question, what are the properties of a physically acceptable wave function, you should write down all these 5 points, and it might give you 2 or 3 marks. Okay, so the last point, even if you don't include, it's okay, but then up to this point is very important. The last point is also important, no doubt, but then sometimes if you give it 2 marks, you're writing down these 4 points, it should be more or less fine. Okay, so this is important. Okay, so this was all about wave functions, and this is what we should actually understand. Okay, now what we are going to do is we are talking about wave function, but what will be the form of that wave function, how we look into that wave function, and so on. This is something which we are going to derive now. So the topic, or maybe I can give you in the form of a question now. Okay, the question is very important. This is something which we are going to do now. So the question is, obtain. So I'm just keeping it simple. We are talking about one dimension. That means the variation is only along, let's say, the x-axis. Time independent or dependent. Sorry, let me take the dependent first. So that means the wave function that we are talking about will vary with time. That's why it is time dependent. Time dependent Schrodinger equation. Why we need to derive it? Why we need to know Schrodinger equation? If we know it, we can actually define the system. We have a wave. We have not yet, analyzed it mathematically, if we want to analyze it mathematically, we should be able to write it down in the form of an equation. Okay, and this is what we are going to do now. But before that, I think we should know something more important, which you might have done in your lower classes, but maybe you have not derived it. Okay, but you might have seen some equations like this, second order differential equation, which also you might have done in your maths class. So in simple harmonic motion, I hope all of you remember simple harmonic motion, class 11. We're basically talking about a motion which will go, to and fro, and there will be some periodicity involved and so on. Okay, so that is actually a simple harmonic motion. If we actually write down the equation of the motion, it will be actually a second order differential equation, m d2x dt square plus kx is equal to 0. So you basically write down an equation something like this, which is a second order differential equation, and you can solve it and you can find out what will be the form of x. Okay. Similarly, in short, and when we talk about matter waves, in place of x we will have psi. So psi is the function for which we are solving. Okay. So this is very important. So if we talk about this simple harmonic motion, and if we write down this equation, what does it do? It actually defines the simple harmonic oscillator. So this defines the equation of simple harmonic oscillator. So we have an oscillator which is moving to and fro under some kind of force, and we want to know everything about the system, its velocity, its acceleration and everything. We should have some kind of equation involved, and this is the equation that we basically have, right? So this is the equation which will define the simple harmonic oscillator. Now the point here is, this is simple, right? Which is something which you have done in your lower classes. But then what I want to know is what defines the particle in quantum state. That is very important. And this is what is wave function is all about. So before I start, I have to give you this logic, and we have to relate with something which we have already done in your lower class. What defines a particle in quantum mechanics? Okay. So we are going to find out what defines a particle in quantum mechanics, and that is actually nothing but the Schrodinger equation. So what defines a particle in quantum mechanics? It is defined by Schrodinger equation. What defines? Schrodinger equation defines. And Schrodinger equation, it depends whether the particle is changing its behavior with respect to time or not. We can actually have two kinds of Schrodinger equation. One is called time dependent, and the other one is called time independent. Okay. So if I do it and if you remember your lower classes, so initially when we are introduced to maths, okay, in our school days, we say that, okay, I have an equation something like y is equal to 2x square plus maybe 3x plus 4. This is the equation which defines the motion of a particle. I want to find out the velocity. I can simply say dy divided by dx, and then I can find out whatever is the velocity. If I want to find it out at a particular time, most of the times it will be a time factor here, and then you can find out dy dt and do it. That's it. Okay, not a problem. Or the rate of change with respect to x, we can do it anyway. So what we can do with this equation is we can define it. Let's say I know what is the x position, maybe it's around 2 meter. So I can put 2 here, and then I can define what is the y position, and then if I look into the coordinate system, I can say the particle will be here. So this is how we define that position of the particle. Then when we have grown up and then we have gone into higher classes, maybe class 11, 12, we realize that the world is not that simple, right? It becomes more complicated. Now we know that there will be the change in the position of the particle with respect to time. It may be having different values of x at different point of time, right? And then what we say is this might not follow this simple expression. It might have some curved motion and so on. Okay, it might not just go straight or a parabola or a hyperbola. Okay, and then we realize that we can actually use a bit of maths, and we can also use it in the form of a differential equation. So this will actually define its acceleration, and then we can actually define the acceleration as well. So we know that now velocity, then we slowly came up to acceleration. We are able to define it, and this will actually define a simple harmonic motion. Now when we came into doing our engineering classes, we know that, or we also knew it from before, but we have not analyzed it mathematically. Now we know that if you're considering a body, a mass, a matter, and it starts moving, it will have some wave associated with it. Now the behavior of that wave is something different, which cannot be defined maybe by this equation or maybe by this equation. So now we need to use a different approach, which is actually a quantum mechanical approach, because the existence of that wave or the existence of that particle at a point will be based probabilistic. Now these equations that we're talking about doesn't talk about probability. So here we have to use that idea, and that's why the entire logic of explaining this becomes a bit different, and we define it in terms of a wave function, and we basically call it as psi, because we are saying that the uh, quantity associated with a matter wave is nothing but a wave. Okay, with a matter or a particle is a wave. So we have to define that. So we have to write down an equation for that, and that equation is given by Schrodinger equation.